I'm only starting here because I was checking this out a couple days back, and about Indian, well, it was like Indian number gestures with hands, which has to do with, calculations. Before there was like papers and computers and smartphones and all that kind of thing, but then of course there's different ways in English and so on to use fingers for counting. But have you ever tried to do this with your pinky without bending your ring finger? I can't do it. I can't do it yet. I once had a girlfriend who tried to teach herself how to double joint her finger, and she did it through years of thinking. Maybe years of thinking will make it so I can bend my pinky without bending my ring finger, but I would be an inadequate ancient Indian calculator because I couldn't perform the basic anatomical operations required for calculating. Another thing I want to get to before I get into the meat of the matter is this lovely multi-layered optical menu with a prominent middle finger, which is symbolically important, considering my next video, which I've already recorded 95% of. And just to drive that middle fingerness home as a theme. Though I haven't figured out the symbolism of the cactus yet. I love anything that's like subtly, reflectively animated. Anyway, still on this dude. Still on, being that I haven't even got to the on that the still on is on this on is. What I mean is my next video is going to deal with this more, but since I'm splicing into the video I'm already on, right. Try to make it quick. This here's my unit circle. If we're dealing with epicycles, this is my I epicycle. This is my square root of I epicycle, which is to say from the square root of I to the 0, the square root of I to the 1, this length here is the circumference of this circle, and when it rolls again it gets to here, which is I squared, or I'm sorry, which is the square root of I squared, which is I. So this circle travels twice to here, or once to here, twice to here, and travels twice around this circle. This circle travels 4 times around this circle. This circle travels 8 times around this circle. So that all adds up. 8 times, 4 times, 1 time, 2 times. But this is the square root of negative I, or the negative square root of I. I'm sorry, that's totally wrong. this right here, and that's separated into fifths. Because that's 5/4. This goes around this green circle, the unit circle, I, 1, -1, negative I. This goes around this 8 times. It goes around this epicycle twice. It goes around this epicycle 5 times. This is the negative square root of I, which squared is I. The square root of I has 2 square roots. So they say the square root of I, root 2 plus root 2I over 2, and then negative root 2 plus or minus root 2I, whatever it is, over 2. But they're not the same thing, because they both sit here. This circle sits here at 0. This circle sits here at 0. So as you bring both of them up to the first power, if you did it at the same time, this one would reach this one would reach this, and by the time you squared them, they'd bring up to each other at the same time here. But this one would have went from here to here, while this circle would have went from here all the way around once and another quarter to here, 5/4, which is what all this measures. Next time I'll use a different construction probably than the Richmond construction, because I found it's not pragmatically useful. Macaroni!